Hello friends, today we will see about the unit 5 of the antenna and wave propagation, that is the antenna arrays. In this we have to see first that is about the linear and planar arrays of two isotropic sources, principles of pattern multiplication, linear arrays of n elements with uniform amplitude, broadside, ordinary end fire, increased directivity and fire array, scanning array, linear arrays with non-uniform amplitude, planar arrays. So these arrays of two isotropic point sources, we have to see about the array system, that is for two isotropic point sources. In that this figure we can see that is the point 1 and point 2, that is from the origin we are considered at the d by 2 places. Whole dimension between these 2 points is d, and 2 points are at d by 2 distance from origin side, and from point P we are considering the different antenna radius, that is R1, R2, and the main radius we are considering R. So in this we can calculate the electric field E is equal to E0 e raised to minus jbr1 plus E0 e raised to minus jbr2. Here beta is equal to k is equal to 2 pi by lambda. Similarly, R1 is approximately equal to R plus d by 2 cos phi, and R2 is equal to R plus d by 2 cos phi. When R is greater than d we are considering, and phi is considering 90 minus theta. So from this we can give the electric field E is equal to E0 e raised to minus jbr into e raised to minus jb d by 2 cos phi plus e raised to jb d by 2 cos phi. That we can equate E0 into e raised to minus jbr into e raised to minus j phi by 2 plus e raised to j phi by 2. Similarly, we can conclude the electric field, that is equal to 2 E0 cos phi by 2 is equal to 2 E0 cos pi d by lambda cos phi. So here value of psi is equal to beta d cos phi is equal to 2 pi d by lambda cos phi, beta d sin theta, that is equal to 2 pi d by lambda sin theta. So here is the two isotropic point sources of same amplitude and phase. So here you can see in this figure and in this figure, that is 2 point sources of same amplitude and phase we are considered here. For that we are considering the electric field E is equal to cos into dr by 2 cos phi, where dr is nothing but 2 pi d by lambda, or that is equal to beta d. So for d is equal to lambda by 2, E is equal to cos pi by 2 cos phi. Similarly, for different angles, that is phi, 0 degree, 90 degree and 60 degree, we can calculate the electric field, that is 0, 1 and 1 by root 2. So HPBW is equal to 60 degrees in one plane and 360 degree in another plane. So origin at element 1 we can consider. So for that we are calculating the electric field for this figure. From this figure we can consider the electric field is equal to E0 into 1 plus e raised to j phi, that is equal to twice E0 e raised to j phi by 2 into e raised to j phi by 2 plus e raised to minus j phi by 2 by 2. That is will be included, that is twice E0 e raised to j phi by 2 cos phi by 2. So normalizing by setting twice E0 is equal to 1, we will get electric field, that is equal to e raised to j phi by 2 cos phi by 2, that is equal to cos phi by 2 for pi by 2. So in this figure also they have shown this. So two isotropic point sources of same amplitude and opposite phase. So same amplitude and opposite phase if we consider for the two element, or the two isotopic point sources, then we can calculate the electric field. For that, E is equal to E0 E plus J5 by 2 minus E raised to minus J5 by 2. E is equal to 2J E0 sin 5 by 2, and that will be calculated twice J E0 sin dr by 2 cos phi. Similarly, here we are considering for d is equal to lambda by 2, electric field will be equal to E into sin pi by 2 cos phi, and for the different values of phi 0 degree, 90 degree and 60 degree, electric field will be 0, 1 and 1 by root 2, and speed VWs will be 120 degree in both orthogonal planes. Similarly, the two isotopic point sources of same amplitude with 90 degree phase difference at lambda by 2, if we consider, there will be the pattern will be as like this. Hence, here is the 90 degree phase shift, they are not equal to each other. So, E is equal to E0 exponential of plus J dr cos phi by 2 plus pi by 4 plus E0 exponential of minus G dr cos phi by 2 plus pi by 4, and we can conclude the electric field, that is equal to 2 E0 cos pi by 4 plus dr by 2 cos phi, letting twice E0 is equal to 1 and d is equal to lambda by 2. We can calculate the E value of E is equal to cos phi by 4 plus pi by 2 cos phi, and we calculate for the different values of phi, that is 0, 90, 60, 120 degree and 180 degree, electric field will be 1 by root 2 0, 1 by root 2 1 and 1 by root 2 for 180 degree. Similarly, two isotopic point sources of same amplitude with 90 degree phase difference at lambda by 4. So, this will be the pattern. So, spacing between the sources is reduced to lambda by 4, and we can calculate the electric field intensity cos pi by 4 plus pi by 4 cos phi. Similarly, for different values of phi, that is 0, 90, 120 degree, 150 degree and 180 degree, that is equal to electric field is equal to 0, 1 by root 2, 0.924, 0.994 and 1 for HPBW equal to 180 degree. So, if you consider two isotopic pattern sources of same amplitude with any phase difference, then considering this figure, so value of phi is equal to dr cos phi plus delta, and the electric field intensity will be E0 into e raised to j5 by 2 plus e raised to minus j5 by 2, and conclusion twice E0 pi by 2. Normalizing by setting twice E0 equal to 1 and E is equal to cos phi by 2. So, two same dipoles and pattern multiplication. So, dipole pattern is equal to E0 is equal to E dash 0 sin phi, and AF is equal to cos phi by 2, and E is equal to sin phi into cos phi by 2, where value of psi is dr cos phi plus delta. So, for dipole AF and final pattern, we can see here for the two same dipoles and pattern multiplication, and for delta is equal to 0, array factor, that is AF, will give maximum radiation in broadside direction. So, in these two directions we can see here. So, pattern multiplication we can see here. So, dipole electric field for vertical orientation will be equal to E0 E dash 0 cos phi, and combined will be cos phi by 2 cos phi, and the dipole pattern will be like this. Similarly, AF and product of patterns will be this. So, this is the array of two dipole antennas we are considering here. Similarly, for n isotopic point sources of equal amplitude and spacing if we consider and if we calculate the electric field, that will be equal to 1 plus e raised to j phi plus e raised to j2 phi plus e raised to j3 phi and so on for e raised to jn minus 1 phi, where value of phi is 2 pi d by lambda cos phi plus delta equal to dr cos phi plus delta. E into e raised to j phi, that is equal to e raised to j phi plus e raised to j2 phi plus e raised to j3 phi up to e raised to jn phi. Similarly, e minus e raised to j phi, that will be equal to 1 minus e raised to jn phi, and that will be equal to 1 minus e raised to jn phi by 1 minus e raised to j phi. So at the last, electric field intensity E is equal to e raised to j epsilon sin n phi by 2 by sin phi by 2. Similarly, sin n phi by 2 by sin phi by 2 for the less epsilon. So here normal sin n phi by 2 by n sin phi by 2. So here value of epsilon is n minus 1 by 2 phi. So this is the figure for the various points 1, 2, 3. 3 points we can show here for the different values or for different distance points and isotopic point sources. We are seeing the electric field. Radiation pattern of the n isotopic element array will be as like this. In this, first SLL is equal to 20 log to the base 0.22, that is equal to minus 13.15 dV is there. At the one side there is RA factor is there, and at the second side is the value of psi is there. And for the different values of n, that is equal to n is equal to 1, 2, 3, 4, 5 up to n10. So these are the radiation patterns for array of n isotopic radiator of equal amplitude and spacing. So these are the patterns for equal amplitude and spacing is there. So broadside array sources and phase. So if you consider broadside array and sources are in phase, if we consider, then value of psi will be equal to 2 pi d by lambda cos phi plus delta, and the value of delta is equal to 0 and d is equal to lambda by 2 if we consider, then value of psi is equal to phi cos phi, and electric field intensity will be E is equal to C is equal to sin n phi by 2 by n sin phi by 2. So this is also for broadside array pattern. So for different value of phi, psi and electric field intensity, that is for 0 degree phi is 0, 90 degree phi by 2 is 0, 100 degree 0 and 1. So DWFN factor, that is equal to 2y01, that is equal to 60 degree. And this is the field pattern of 4 isotopic point sources with the same amplitude and phase and spacing of lambda by 2. So ordinary end fire array we are considering for the end fire array system. Then value of delta is equal to minus phi and value of phi equal to phi cos phi by cos phi minus 1, and BWFN is equal to 120 degree. The field pattern of ordinary end fire array of 4 isotopic point sources of same amplitude, spacing is lambda by 2, and the phase angle is delta, that we have considered, is equal to minus pi, and for that will be the field pattern for the different points. So increased directivity and fire arrays. What is meant by the increased directivity for the end fire arrays, that we have to see here. So how the directivity can be increased. So here we are considered phi is equal to dr cos phi minus 1 minus pi by n, and then would add criteria. Here we use psi is equal to dr cos phi minus 1, and E normalized will be equal to sin pi by twice n into sine n phi by 2 by sine phi by 2. So if we consider the parameters here, ordinary end fire array and fire array with increased directivity, then SPBW is equal to 69 degree, and for end fire array 38 degree. FNBW is equal to 106. Here for end fire is 74 degree. Directivity will be 11, directivity will be 19 for end fire array. So how the directivity will be increased here, that we can see in this figure. So in this pattern also we can see of end fire arrays of 10 isotropic points. So say for equal amplitude spaced lambda by 4 apart. Phase for increased directivity, that is delta is equal to minus 0.65, and for phase of an ordinary end fire array, delta is equal to minus 0.55. So if we consider array with maximum field in any arbitrary direction, then we can see the for B maximum at phi is equal to 60 degree, psi is equal to 0, that is dr cos 60 degree plus delta, and delta if you consider minus phi by 2 for this array system. If we draw the pattern, field pattern of array of 4 isotropic point sources of equal amplitude with phase adjusted to the maximum psi is equals to 60 degree, and for spacing of d is equal to lambda by 2. So this spacing is lambda by 2 in each. So in this way we have seen here the different points related to the antenna array system. Thank you.